Okay, so this is week 8 discussion problem. Number 1 is organic compound nomenclature. So organic compound nomenclature start with identifying the functional group and finding the longest carbon as a chain backbone. So you see here, you see the double bond. So this is where we're going to include what is called the backbone of the molecule. And starting from here, this carbon shown up, we can go this way having 3 carbons, or the other way is shorter. So this will be my longest backbone, and that will be my choice. So having said that, I am going to rewrite this. The backbone is 1, 2, 3, 4, 5, 6, 7. Okay, 7 carbon backbone with double bond on carbon 2. So you can count the carbon from left to right or right to left, but what matters is to make the smallest carbon number as possible. That's a key point from the one end. So therefore, this is for me 1, 2, right? So okay. So 1, 2. There's something going on here. Okay. Oh yeah. Okay. It was a text. Okay. 1, 2, 3, 4, 5, 6, 7. I just finished numbering the carbon, and this carbon 2 is the position of the double bond. And so this one sums up to saying that, okay, this is called 2-heptene, and E means double bond, and the 2 is a number of carbon number where the double bond starts. And then the unit, so that's the backbone. And then you need to know the attachment here. So on the position of carbon 4 and the carbon 5, you have a 4, 5 dimethyl, right? And you have a position 4, you have a ethyl. And so now I need to kind of set up the priority that which one comes first, which is alphabetical order. And so this one, M being counted, di means number 2, so it's not being counted. So what is being counted here is under the 2 lines, M or E. This one, ethyl comes first. Okay, so therefore, finally, the answer is 4 ethyl, 4, 5 dimethyl, and then hyphen with 2 heptene. Okay, so that's the answer. One of the other good practices, once you write this one, you should be able to draw the organic compound shown up on the side as shown like that. Okay, let's look at the second problem. So this compound has an aromatic group. So aromatic is really serve as a backbone and quote unquote a functional group. Okay, so therefore it is going to say that we are going to say the backbone is benzene. And then from here, the bromine is a bigger one, so we're going to count it 1. And we can count either way, clockwise and anti-clockwise, counterclockwise and clockwise, but we want to minimize the numbering. So therefore, we want to count it this way to have a smaller number used to say the location of attachments over there. Okay, so therefore 1 bromo, 3 ethyl. Okay, so this is a 1, and then this is a backbone, and this is your attachment. And so putting them together, you are going to say B versus E. So 1 bromo, 3 ethyl, and then because this backbone does not start with a number, I can just, without using hyphenate, we can just say benzene. Okay? So that will be the answer for the second compound. Once again, once you have these things look like that, you should be able to draw it like this. And if you're looking at the aromatic compound section, there is another name for this, which is meta bromo ethyl benzene. So this is another name that organic chemistry prefer to use, and what that means is bromo and ethyls are attachment to the benzene, but they are in this what is called the meta attachment. So when you're looking at the benzene, meta is a position of the di-substituted position, and this is a meta di-substituted position. The whole spelling is META, and we just call it M in the nomenclature. Okay, so let's look at the third compound, which is start from the backbone of the molecule, also the kind of the class or family of the molecule, starting from the functional group. As you can see now, you see this ester group, okay? And this ester group kind of belongs starting from acid, reacting with, let me use a different color, the alcohol, okay? So when you react an acid with an alcohol together, you are going to have that. And also, it is actually good practice for you to kind of looking at it as, okay, this is an alkyl with CO with an R prime. That's what we call ester. Okay, and in a very simple way, you need to say something like this one comes first, alkyl, and then you need to have this one based on that, and that's an acid, so with the O8. Okay, so that's how the ester being nomenclature. So let's look at the, let me use a blue color to represent this alcohol-based one. This is a isopropyl. Right? So this is an isopropyl alcohol. Isopropyl is the alkyl name going in front. And then the one that goes on here, I need to count the number of carbons. And this one, this is definitely the number one. I need to count the number of carbons in organic acid. 1, 2, 3. And from here, you can continue to be like that to find the longest path. So this is a sort of the backbone within this organic acid component in the ester. And then this is what you can say in your mind is, okay, 5 carbon acid with methyl on carbon 3, right? So how do you put that this thing is in the nomenclature languages? And that one is okay, so methyl. So methyl. So there are 3 methyl, right? So 3 methyl and pentanoate. Pentanoate. So that's the end for the ester end, just like it's shown up here. So you just need to have a 3-methyl pentanoate. That's what it means by methyl is attached on carbon 3 position, where the backbone of the acid portion is 5 carbon base. So now finally, now you're putting those two together. The answer is isopropyl. And then because the names, the backbone, the parent start with a number, so you need to put hyphen with 3 methyl pentanoate. Okay, So this is a nomenclature for the number 3 shown up here. The last one is also, once again, start with identifying the backbone. So this is an aldehyde group, and starting from here, let's count. And for the fun of it, actually, it doesn't matter which is the backbone, so that would be my backbone choice, because either way, it's the same number of backbones. I want to just show you there are multiple ways of doing the same thing. So, but most important one is, this one is a carbon 1, carbon 2, carbon 3, and carbon 4. Okay, so my backbone is 4 carbon based aldehyde, right? So this is aldehyde. So that means what? Butane, butanol. That's an aldehyde. And so, and what's my attachment here? In the position 3 carbon, 3 methyl. So therefore, all you gotta do is combine those two, find the final answer, which is a 3 methyl, and no hyphen because it's not a number, butane, butanol. Right? So that's an aldehyde, and that's your attachment, and that's your backbone. Okay, so these are the 4 problem set I have shown in here, starting from A is an alkene, B is an aromatic compound, C is an ester, 4 is an aldehyde. And this is probably one of the reasons that you are being asked in the last week about functional groups and families of organic compound, and because that is used to essentially define and know how to write a nomenclature. Thank you for your attention.